Good afternoon, ladies and gentlemen. We are here again for another amazing talk that we are going to hear today in EuroStruct LiveTalks. My best regards from the stormy Zurich. We have just outside the big storm going on at the moment, and we are going to enjoy our lecture today with Agnieszka Bigaj van Vliet. And I'll pass over to my co-moderator. He's going to present himself. Please, Alfred.
Yes, welcome also to this live talk. My name is Alfred Strauss from the University of Natural Resources and Life Sciences, and I'm happy to have you here today for this live talk. So that's from my side.
Thank you, Alfred. Our today's speaker is a very prominent speaker. Dr. Agnieszka Bigaj van Vliet is a senior expert in the field of safety and durability of structures. She is a senior scientist in the Department of Structural Reliability at TNO, and she holds the master's degree from civil engineering from Warsaw University of Technology in Poland and PhD from Delft University of Technology in Netherlands, and has over 20 years of experience at Netherlands Organization of Applied and Scientific Research, TNO, in the Department of Structural Reliability. She coordinated quite a few of research programs at TNO. She's also in 20 to 2024 ERP CS Smart Sustainable Concrete Structure with circular solutions based on recycling and reuse of construction demolition waste, and also at ERP SI Data Informed Assessment of concrete bridges with corrosion damage supported by structural health monitoring and probabilistic numerical analysis. She is presently coordinator, this is actually quite interesting, of EU Horizon 2020 CSI project I Am Safe, which is also Alfred Strauss involved in it as my co-moderator, which aims to formulate input into IEC mandate to send to the Committee European de Normalisation to prepare a new standard in monitoring optimal maintenance and safety of transport infrastructures. She is also a member of Presidium of Technical Council of the International Federation of Structural Concrete, FIB, and head of a Dutch national delegation to FIB and deputy convener of the FIB Task Group Model Code for Structural Concrete. She is also a member of Subcommittee 318L of the American Concrete Institute, ACI Committee 31825 Structural Concrete Building Code. She is now today going to tell us something about toward effective standards for monitoring, data informed safety assessment and maintenance of transportation infrastructure. And this is going to be focused pretty much on the project of I Am Safe, and we are very excited to hear from you about this project and about your work. So, Agnieszka, the podium is yours.
Thank you very much, Rade, Alfred, and welcome to this presentation. Indeed, I will be to a large degree sharing with you the outcomes of the ongoing European project, but also trying to discuss with you what kind of needs and what kind of opportunities are there to change the approach that we currently use to the assessment and to maintenance of transport infrastructure to make it more rational and better supported by data. As Rade said, the project I'm Safe intends to provide input to future mandate for SEN for changing the standards. But before I will go into more discussion about the standardization issues, I will start with a few notions about the context of this kind of innovation and research activities. You have probably heard it countless times that there is a political, societal pressure to keep infrastructure reliable and available and to provide the service at acceptable costs. Well, the demands on the infrastructure are additionally increasing because we aim to improve sustainability of the built environment. And from that perspective, service life extension is considered a very effective option to reduce environmental impact. So what we want to have a situation in which, despite the longer service life of the structure, the investments will not increase beyond what is foreseen, and at the same time will not deliver the quality of service. We are in an unfortunate situation that we have already observed that we have issues with infrastructure. There are situations in which tragic events took place. Genoa bridge collapse with over 40 people losing their life, and then huge disturbance to the traffic in the region of Liguria only is an example of the situation. There have been multiple bridge failures, and the experience tells us that we can give improvement to the policies of maintaining and upgrading structures when we are using information. Well, optimal maintenance, as it says stated here, requires timely and accurately available information. Well, monitoring is an opportunity to have access to this kind of high quality information. But there are also situations in which you have to ask yourself whether monitoring is the best or the only option. The bridge collapse, very recent in the United States, was quite likely a result of the landslide. Are these situations in which we can also rely on monitoring? So where are the limits? Where are the limits for application of different techniques? What to monitor and how to use that information? We are also lucky that we have another example in which you can say that information can prevent major collapses. The photo below shows results from the inspection of the bridge, also in the United States, with the major crack being observed, and in time to close the bridge for the major repair. Well, the side notion to that is that this crack has most likely been there for last 50 years and have not been observed before. So limits of detection and availability of data, how to deal with that. This will be the few of the points that I will be trying to discuss. And as you see, focusing in the first part on the challenges and opportunities for data-informed assessment of structures, then going very fast into the topic of decision-making to see in which, to which degree information can be of the use also in that process on top of use in the safety assessment. And the second part of my presentation, I will dedicate to discussion of the role of standardization, but also the challenges in having standardization developed in such a way that it supports and not constrains the users. And if the time allows, a few sentences about digitalization. When we are talking about the risk-based and data-informed lifecycle management, we have to think about it in context of the differences between new and existing structures and opportunities that it creates. Well, one of the major differences is that for existing structures, we do have access to information, and we do have access, or at least we can have access to the information that is relevant, and we can collect that information. Cumulative knowledge of the performance of the structure during the life cycle is something that is of huge value. And what kind of information are we talking about? For existing structures, we can collect the data in different stages. So we can have information from the design and construction stage, and we can also intensify our efforts in collecting relevant information during the operation of the structure, operation in use. This information can come from different sources. This can be facts or records from the documents, but this can also be observations that we can make while gathering information about the state of the structure or about the factors influencing that state. And as you may see in that slide, the sources of information are available to different players. there is information that is in hands of the users and owners. The particular type of that information is information regarding the requirements that they want to assess to their assets. There is also information that is very specific to certain stages in the life cycle, the stage of the repair and interventions in which the condition of structure or condition of the use of structure may significantly change. It's also very significant a moment for which the information can be collected. But also the effects of the factors that are working on structure to change of its condition. So when we look at this kind of differences between new and existing structures, we can group them in certain categories. As I said, we have this access to the information, but what is more unique to the existing structures? Well, one of the important differences is the change in the magnitude of costs that are needed in order to increase performance level of the existing structures. The cost of safety measures for existing structures are higher than in case of new design, and I will in a minute discuss how that influences the assessment, or in which way we can take that into consideration in assessment. The same discussion will also deal with the change or the difference in the service life or residual service life of the existing structures is usually shorter than the design life of new structures, and we need to be able to take that into consideration in the assessment. And one of the questions is how to do it. The knowledge levels, as just touched when I was showing this cumulative knowledge collection throughout the life cycle, and but brings information. But we need to handle this information with care, also with the understanding of uncertainties in that process. And just a very last notion, deterioration mechanism, changes of the condition of the structure in time, the one that have been expected, but also the one that may be come as a surprise. How to assess that this processes take place, and also how to make a choice of appropriate models to consider that in the assessment. Now, going into a few of these aspects in more detail and trying to see how can we handle that. Assessment of the existing structure, as I say, has to do with the objects for which the costs of increase of the performance levels are higher than in case of the new structure. And you see in this diagram below comparison of the costs for building a structure and for increasing its reliability level in case of new structure in the left, and in the right, similar comparison or summation of the costs, but for the existing structure. And since these costs of the improvement of the safety level, upgrade costs are higher, but we also see that in case of cost-based optimization, we arrive at another optimum, which means that we may consider from the economic point of view that there is another target to be formulated for existing structures comparing to the new structures. In fact, what it means, we need to be prepared to pay the costs of improvement or of our infrastructure and keeping them in use. Well, in the future, this may even become more complex when we will add to that discussion also the cost of benefits of structures with regard to environment and impact on that, on optimization. This kind of consideration have been already taken into account in different groups that are working on setting up the framework for assessment. Here you see the example of the results that have been produced with regard to concrete structures within the work that is being done for the new model code for concrete structures by FIB task groups. And two of the important changes with regard to design, which I would like to bring to your attention. The first one is with regard to this target reliability levels. As you may see, there is a distinction between the target reliability level for new structures and target reliability level for existing structures that are considered fit for use, and also target reliability level for upgrade and repair, a level indicating an optimum when upgrading an existing structure, which fall below the desired performance level. Well, the numbers given in the table are results of the optimization. See them as indication, and of course, there are different reasons why they could be different for other situations. One of the reasons, when we are talking on a broader scale than European scale, is that there could be an effect of accounting for the certain level of acceptance of costs in different parts of the world. One other thing that is also important in context of this table is that it has been proposed to adapt an annual approach in both in design and in assessment. And actually, for design, this would not yield any difference comparing to the design that would be performed with the reference period of, for instance, 50 years. The reliability levels have been calibrated in such a way that their design will look the same. But in case of the assessment, this is of true benefit for the user, because then instead of having the non-relevant reference period, we really can assess the performance of structure and its fitness for use at different moments according to the foreseen extension of the service life that we want to do. And this is a basis for further calibration of partial factors, which I not show here, but you need to understand that setting the target reliability levels will be of the straightforward impact on the values of the partial factors in case calibration of the partial factors is conducted to facilitate semi-probabilistic evaluation format. Well, now we are talking about evaluation. And when we talk about evaluation, we need to talk about the way how we will deal with the uncertainties in evaluation. And uncertainties in evaluation are inevitable. Yes, we do have different reasons for that. We have reasons that are inherent, the materials and the processes have their random distribution, aleatoric uncertainties stem from that. But there is also another source of uncertainties in assessment, and this is attributed to lack of knowledge. And lack of knowledge can be, again, of a different origin. There can be lack of knowledge that is simply us not understanding how the systems are working and how the processes are working. But there is also lack of knowledge that is a consequence of not observing. This diagram attempts to represent this information uncertainty at the various stages of the design and service life of the structure. And in a very simplistic way, it illustrates that when we start a design, we do not yet know how the structure will look like. So our knowledge of its performance is, of course, limited. The moment we complete the construction successfully, we do have structure as built. This could allow us to assess a high level of information. And after that, we can follow different strategies. We can follow a strategy in which we just do not observe or periodically observe only while the system is undergoing changes. And these changes can be an effect of system limitations, different circumstances of use of different factors influencing the use, for instance, deterioration of damage. There can be also changes in the condition of structures that happen on the occasions of interventions. And these observations can be made, and in knowledge of the performance can be improved and supported by data. In such a situation, our knowledge is higher. Well, what does it mean when we go deeper into that? It means that we are able, based on the information from inspection, monitoring, and testing, reduce certain parts of the uncertainties. Not all, as I say, there is this aleatory variability of processes and materials, which is inherent, and that cannot be reduced by obtaining information, but we can use information in increasing other substantial parts of the uncertainty, statistical uncertainties, or other parts of the uncertainties that are more related to the modeling uncertainties, for instance. In design and in assessment, it is essential to take into consideration all these types of uncertainties. And which uncertainties are this? Well, I will try to illustrate and discuss that, taking as the reference something that you probably know very well. This is the treatment of uncertainties in structural design by partial safety factor format, and in which we do have uncertainties associated with different components of that approach. On the side of the loads, we do have load models, and these models are, of course, stochastic models. So there is an uncertainty in this kind of models. We can quantify it. And in terms of, in context of partial safety factors, it's here indicated as gamma small f. We do have also models that we use to model action effects on the systems. And again, these models have also their modeling uncertainty. Both contribute to the gamma F capital, which is the uncertainty on the side of the loads. On the side of the resistance, in a similar way, we have material models with the associated distribution and associated uncertainties. We do have resistance models with the modeling uncertainties. Both that contribute to the uncertainty on the side of the resistance. Well, when we perform modeling, or when we perform design, we aim to have a certain optimum. But of course, and this is indicated in this dark gray line, the reality is a bit off our models. So the models are conservative. And this is the principle how we proceed with the design. What happens when we are going into assessment? Well, when we are going into assessment, then we start from, again, from models, and we start from the best models we may have. And in a similar way, we will have to quantify uncertainty in terms of load models and action effects models. And we will have to quantify uncertainty on the side of the material models. And you will not be able to see it, but if you would replay this presentation, you would see that we may also expect that there is a change in the distribution of the properties of the materials, because we may have to deal with the consequences of deterioration of damage. And there is also probably a change in the loads. We know that we have trends in loads development. The structures have been designed for different loads that they are now have to carry. So this changes may eventually lead to the situation that, as it is shown in this center of the figure, limit state evaluation does not lead the result that we would like to have. We may end up in the situation that we have to say the structure does not fulfill its requirements. The resistance is not sufficient to carry the loads. Well, is it true, or is it just our perception? And this is what we try to illustrate in this diagram. If the dark green represents again the reality or the model of based on aleatory uncertainties only, we see that there is a huge space that we can explore, and we can, in a rational way, by reducing uncertainty and improving our modeling, shift towards closer to the reality, and by that, hopefully, declare structures for fit for use. And this shifting towards reality can be a benefit of data. It can be direct benefit of information. Now, when we are talking about information, it's good to understand that we have different sources of information in assessment. We have a direct information, which is related to the quantity of interest, as it says here. Quite often this will be material properties, or for instance, the loads. But we can also have access to indirect information. And this is more on the global response level quite often, or on the level of the action effects. And here we have different ways to benefit from this kind of information. For direct information, we can rely on updating basic variables, and for instance, by Bayesian updating. In case of indirect information, we can either try to update the models, or we can eventually, in different evaluation formats, update the probability of failure directly. This approaches can be captured into frameworks and formats. And here it's an example how this could work in a case when we are using partial factor method. For instance, when updating resistance and action distributions is done with the Bayesian approach, and with the partial factors are adjusted to account for the direct information about the distribution of the certain material properties. And of course, what is very essential, including adequate models to account for the phenomena that are influencing behavior of the structures. When we are using a global factor method, that is usually done in case of numerical analysis, this is in concept similar, using model data to update the models, or using information to update the distribution of actions and resistance. This is not only theory, we have also practices, examples in the practice. When this kind of advanced assessment took place. Here you see the pictures describing the example of the Dutch field lab project. In that case, on the Van Brino Noord Bridge, which is one of the busiest bridges in the Netherlands, a steel structure, the fatigue crack growth have been monitored with acoustic emission technique. And based on this monitoring data and additional condition state data, and using detailed fracture mechanics based models, the simulation of the fatigue behavior have been performed, enabling improvement of the prediction of the time to failure. This kind of approaches can be very well implemented also in an early warning system, or in even in real-time prediction of fatigue surface lives. Another example is when we look at the updating of the information on the actions. One of the main sources of uncertainty in the assessment of structures is uncertainty about loads. And it's also very important to be very prudent in choosing which part of the modeling we will attempt to improve. So the most dominant uncertainties are the one we should target. We have also very good examples of the practical applications in which based on the such, like in this case, again, a Dutch example of the field lab Moerdijk, the bridge VIM monitoring data have been analyzed and processed to improve understanding of the live load on infrastructure. Based on that, we are able to derive traffic log models from monitoring data, and these models can be used in the assessment. Of course, the expectation is that this case-specific models will be lighter than the standard models that are provided for overall asset assessment. We can have object-specific or network-specific models. This is also bringing a huge benefit to the improvement of the assessment. Well, more of this kind of examples you can find in the online database that have been created in the I'm Safe project, and they are quite different, so it's worth having a look at that. Well, as I said, I also wanted to touch the issue of the decision-making in the context of asset management and maintenance. And what has also been proposed in the I'm Safe project is the workflow in which information is included. And when I say information, data, I need here to introduce another concept, a concept of key performance indicators, which is a concept that allows to be very clear in which kind of observation is meaningful in context of certain level of assessment and certain type of questions. And I hope that you somehow can read this slide, but if not, then I will try to help you by enlarging certain parts of it. We do distinguish in different levels of demands in assessment, and which is quite often a function of the criticality or the risk level for the parts of the assets or objects within the network. In the certain low risk level, we could work with another processes, routine as maintenance, simplified assessment, and appropriate set of performance indicators. However, when we go into the more demanding types of structure or more demanding situations in which the criticality of structures demands a higher accuracy, we would need to refer to other types of indicators. And as I said, slightly enlarging this figure on the when here it's only zooming in on the part of the assessment process and decision-making process that could be applicable for the low priority structure, say to the structure for which the risk assessment yields conclusion that the criticality of the structures is acceptable to have that kind of approach. And here the routine maintenance and would be performed. Condition survey would be done on the low level of demands. Sometimes visual inspection will be sufficient, and simplified measurements conducted on the with a large inspection interval would be enough to control the anomalies and continue maintenance. Of course, this diagram is missing the what if anomalies are not acceptable. This you can see in the big diagram. What in case we deal with the structures that are quite demanding, structures with the medium priority or high priority, and in particular the structures for which decision is taking the structural health monitoring is the level of the following the condition development or the action development for the structures that is needed in order to facilitate the process. There we have to consider a different complexity of the system and look at which level we would need to gather the information, whether the monitoring should take place on the key component level, and we can perform the diagnostics based on the anomaly detection on the key component level, or do we need to rely on the modeling of the whole structure, then perform the data analysis, which are far more complex, quite often requiring model updating, and take decisions based on this kind of analysis. In any case, very essential part of that process is setting the alert levels for different decision-making aspects, and we can have alert decisions, alert levels for early warning that could trigger more detailed investigation. We could have alert levels that trigger maintenance and interventions, but we may also have situations in which we need to trigger the extreme alarm levels and could be in a case of accidental actions that make structure completely unfit for use. Having that automated and digitalized is, of course, quite inevitable, since we are talking about a more complex analysis. And here we also call it a level 3 key performance indicators. And now, what does that mean, key performance indicators, and how to choose them? This is a very complex and very essential question. When we do proceed with monitoring, one of the most critical questions is what to measure, and what accuracy of this measurement is required, what frequency of this measurement is required. Here we are looking at the part of the knowledge that has been developed in the course of Cost Action 1402, where they came up with certain suggestions of the particular key performance indicators that are fit for use at different levels of assessment, and in context of prediction with the very complex models, but also in context of decision making in the context of routine maintenance. This kind of information you can find in reports, to which I would very much like to point your attention, because this seems to have a high practical value for the users. Well, now I'm going into standardization, yes, because that was actually the purpose of having that introduction. Now, what we do observe is that structural monitoring is already in use, and there are quite successful attempts to develop guidelines to facilitate that process. And when we are talking about facilitating the use of information from a monitoring, then we are talking about different types of issues that need to be resolved. We are talking about the issues that are related to setting up the monitoring system. We are talking with the issues that are related to processing data, issues of the assessment, but also, of course, issues of the risk evaluation and prioritization of structures for the maintenance. And what we have done was to investigate which is the status of the current development of the standards. As you see, there are numerous. What they have in common, they all attempt to use data in an efficient way and facilitate that. Most of them are risk or reliability based. And there again, there are some differences, some very substantial differences in the way they treat different aspects. I was discussing in the beginning this differentiation into reliability levels for new and existing structures. This is implemented in the Dutch standards. This is not implemented in every standards. We were showing the framework for assessment and decision making, which is quite well implemented in the Italian standard on risk management and monitoring of existing bridges. So what is the feeling that we have? There is a lot available, there is a lot of thinking, but we are actually missing harmonization of these approaches. And what we are actually missing is that taking that to the level of the European standardization in context of the already existing standards, because of course we do have a very well developed set of standards for design of structures relevant for transport infrastructure. We are in the process of reviewing the Euro codes also for the existing structures. So we are expecting and anticipating certain changes in that domain. And it all opens possibilities. And at the same time, we see that this set of standards do not facilitate everything. If we indeed want to have this transition towards risk-based maintenance management and more preventive maintenance strategies that are taking benefit of information, we need to go a bit further, and we need to formulate principles and requirements for structural monitoring. We need to make sure that the data-informed approaches are well implemented in the codes for assessment, and we need to have also some improvements in the practices, also improvements facilitated by standards with regard to maintenance management and condition-based maintenance strategies. With that idea in mind, we do propose in the course of the I'm Safe project few developments in terms of standardization. The first one involves having a new standard on structural monitoring for infrastructure, since we do not have one. And this should provide the principles for using and setting up monitoring system in order to produce meaningful information for the assessment and diagnostics. We do have to take care that the amendment of the Euro codes is brought further in the sense that we do open more possibilities for using data-specific data-supported approaches. And since we know where the current revision is going, we are trying to take a next step. And then the last but not least, we also need a new standard for maintenance of transport infrastructure that is improving the decision-making process. Now, in only single highlights of what is or what could be the additions or the objectives of having such a standard. And again, before I will go into more detail, I will repeat: the standards must support, standards should not constrain. So we are talking about when talking about standard for structural monitoring, it's important to have principles of having principles of setting objectives of structural monitoring, having support for methodologies for translating data into information. And this is more related to data processing and pre-processing and all processes around that. And we also need to keep in mind that technology in the domain of sensing and monitoring is still developing, and that development is not going to stop anytime soon. So openness to innovation is one of the main constraints under which the standards need to be developed. And again, you see here in this bullet point list below that what we are thinking about support in definition of the objectives, support in choice of the monitoring type, monitoring techniques, and setting up the requirements for monitoring, and also design of the monitoring systems involving rational decision-making with regard to choices, amounts, and placing of the instruments used for the monitoring. With regard to further amendment of existing Euro codes, and I'm now talking beyond the what will be achieved in the ongoing revision. So we are also talking about the period after completing the current revision. Here, the important things is to have that perception and that reliability requirements may be different from new and existing structures, that annual approaches to assessment will have significant benefits in assessment of existing structures, and that this can be a way to go. Another important thing is taking into account deterioration and damage. Appropriate models which will have the reduced uncertainty comparing to the models that do not appropriately account for the effects of deterioration or damage are needed to be able to perform assessment of structures in which these aspects play a role. And also use of structure-specific information, for instance, structure-specific information related to traffic loads, can be of huge importance in data-informed assessment. And with regards to a new standard on risk-based and condition-based maintenance strategies, here we are again talking about principles of decision process, Here, particular attention could be given to formulating the key performance indicators and choices of these indicators at different levels of decision making and different levels of assessment. Sorry. And also the aspect of risk-based process of prioritization of assets for maintenance should be considered. One of the very important aspects that is here explicitly mentioned is documentation and collecting of information. I started with cumulative knowledge. Well, it is an opportunity, but it comes with the need of setting a standard for having this information collected, organized, and analyzed, and also available. This brings me to the very last point that I was hoping to address, which is the digitalization. Digitalization as enabling technology. We do have already now examples like the one shown here from Spain, in which the data platforms are being created, and with the objective of supporting the users in collecting, keeping, analyzing data, and processing data towards meaningful information. Now, that data is the topic for which standardization needs are also relevant. IMSAFE project does not explore that to every detail, but in any case, what we do suggest is identification of the standardization domains and proposal for having certain approaches in standardization, but also this very important notion that is on top of that page. Data should be findable, accessible, interoperable, and reusable. Very generic and yet very fundamental. When we are talking about the future improvements of our practices, this needs to be kept in mind, that we may be hindered in the future if we do not take care about the, generally speaking, quality of our data assets. So in summary, what I could say is that we are quite lucky, because we are now in the moment in time that we do have a lot of technology development made available to us, and we do not need to wait for much more in order to be able to start using monitoring as a valuable support in assessment and maintenance decision making. We would also have a lot of know-how across Europe, also manifested in this national attempts to develop standards, for which we can benefit in trying to have a harmonized European approach to standardization. One very important thing is acceptance. So here we have to be very aware of the fact that there are different practices across Europe, and we have to connect to these practices when developing provisions and proposals for standardization. Our attempt is, our aim and objective is to prepare input for that kind of process with the solid background that will enable formulation of the mandates that could be taken by SEN as the basis for their activities towards further development of harmonized European standards. And with that, I would like to finish the presentation, and we'll be glad to take your questions.
Agnieszka, thank you very much for this very interesting presentation with many aspects and insights into the CSA IMSAFE project. I think it was really appealing and gives a very deep insight in this project. Maybe I can start with one of the first questions, since you presented now a very huge amount of work there. And I think it's very interesting what is the timeline in particular to bring it to the SEN code format, and then maybe after the SEN code format to bring it back to engineering practice? Maybe you can give us here some more insight.
To which I will only attempt to give an answer. Yes, because of course it's not exactly I'm not exactly the decision maker in that process, but I can inform you about what we are able to plan and what is likely to happen afterwards. Yes, the project I'm safe will be completed in April 23. So until then, we will be working on formulation of and solid background to the proposals that we intend to make. We are in communication with relevant SEN parties and also European Commission DGs, who are the one who may take initiative of mandating SEN or stimulate SEN, although there are probably also other groups who could be set up such an initiative. It's unlikely that that process of further amendments, further development of standards will interfere with the ongoing process of Eurocode revision. It would not be also beneficial. So you must look beyond that horizon, and that's already makes us a bit of depending on when does the process of the revision of the Eurocodes will be finalized and complete. We know that they are progressing very well, but still there is this issue of planning. So I think you are not talking about next 2 years, yes, but there is also something that I think should also be worth mentioning. While preparing the input to the mandate, we also organize the knowledge. Yes, we organize these proposals. So a lot of the things that are not yet maybe so on the fast track for implementation in the harmonized European standards can be already of relevance for the one preparing the standards or guidelines on the national or operators level. That's the one thing. And the other thing is that, of course, there are also stages in between, yes, and on top of the European harmonized standards, we also have technical specifications. We have different types of documents with different status, and this kind of output of the project could also at certain moments be a basis for creating this kind of deliverables.
Okay, and maybe one additional question from my side at the beginning. In particular, there is of course a big interest from practitioners and also researchers to see all these elements that you're collecting now, we are collecting in the project. Will there be a best practice or some platform to see how these elements have to be joined together and how the decision process, starting from the inspection up to finally to risk-based decision is?
Yes, I already mentioned at certain moment the online I'm safe Wikipedia, which I will try to scroll back so then you can see again maybe the link to it, because of course this is nice if people can find it. Yes, this one. We have developed an online repository of huge part of the knowledge that we have collected. As I mentioned, there is a collection of best practices in monitoring of infrastructure, but we also expand that, and this will be completed shortly, April, path in which we will present best practices or the good practices in using the data in this kind of analysis flows for the purpose of supporting decision. And what we are also trying to do there is to show these different alternative paths that fit with different classification of the criticality of the assets. So in the Wikipedia, you will also find examples of the decision-making which involved monitoring and decision-making that involved routine maintenance and the associated inspection levels. This is I hope, to some extent also showing how all these elements work together in practice.
Okay, thank you very much. Rade, maybe you have from your side some points.
Yes, thank you very much for the talk. There are really not questions coming in that that are related directly to your talk. There was one question which I think is related to the mandate that you have for this I am safe, and I guess you just cleared that up. That is Horizon 2020 project. So you don't have a mandate from European Union
we are not,
to do
as
something.
I say,
yeah.
I hope I was very careful in my formulation.
Yeah.
We are preparing input to the mandate. Of
Exactly.
course, we are not drafting the mandate.
Exactly. So that's I actually already answered that question, but just to keep you updated. The one thing that is kind of interesting from a practical point of view, of course, is you know, the level of education, the people that are able to implement such methods is not very broad basis, right? There is if you look in the European infrastructure, we have in Switzerland, for example, we have roughly 15,000, 20,000 bridges. We really don't know, and other countries go in the direction of 500,000 bridges and so on. So the question, and these are of course getting older. So how do you think how we should proceed with regard to education? You're also involved with there. To be sure that the people that are coming out of our universities are able to apply these methods. I mean, this is not a very simple stuff, in particular if you look into the thing that engineering is currently not so popular.
Yeah, I think that's a very good question, and I think it's also a very good point to discuss it with a large audience, because many of us are probably in different ways involved with education. Yes, either professional education or academic education. Well, before I will go into education, I would like maybe say something additional to that. Yes, rather you were mentioning this huge amount of assets that needs to be taken care of, for which we need to take decisions. And I think that important thing is also, and we are still on that page, that I can say that to differentiate in different classes of the risks for the infrastructure and apply appropriate processes in dealing with that, so that at least we can efficiently use the resources that we have. Yes, also human resources, and some of that assets require more simple approaches, for which the skills are the skill requirements will be less, and does not mean that they are less important, because all of that assets influence the well-being and transportation, but that's just the fact that demands are less, so the complexity of the activities is also less. So being also selective in what kind of assets are treated with different approach enables us to efficiently use the human resources and the skills. The other thing is, I do also believe that standardization can benefit education in a certain way, yes? Because that's not only that it, when rationally set up, it should have this clarity of also explaining why things are being done and why they should be done. It helps us also to avoid human mistakes. That's one of the benefits of standardization. So here I also see the benefit of having that clear and having that guidance and support to which the users can refer. And another thing is indeed the education on many different levels. And I think that we have different needs. The complexity of the issues becomes larger, so we will need also to work with different disciplines. When I was mentioning digitalization, it's also mean that we need different skills for a part, at least, of the support. And well, that's that you are right. We need to align our education programs, and we need to align our human resource policies if we want to have that implemented on the meaningful scale.
Okay, there is a question from audience which is also referring to the question of mandate. I'm Swiss, so I'm not really in European Union, so maybe I misread it completely. But the question was, given that you are producing inputs for the standardization, the question was related under which what is the reference European legislation for your input. And I'm sorry, I cannot really, I don't know all the inputs in within the European Union. So maybe for you it makes sense, this question. I'm not quite sure. I'm not sure.
I'm not exactly sure if I understood it correctly, so I will just probably try to repeat it. The projects as such, as a project granted by the European Commission. So the deliverables are delivered to the European Commission and made available to other parties, which has been also explicitly invited to be a stakeholder in surrounding the project. We are therefore communicating with the SEN committees 250 and also 319 for maintenance, in order to inform them about the course of the project, but also about the proposals that we intend, in fact, to endorse. Yes, again, that's what I say. We do not prepare a mandate. We prepare a proposal that could be considered for mandating SEN. That decision-making in mandating, this is a legal process in which the project does not play a role anymore. That's beyond our project obligations, but also our project influence. I hope that to some extent answers to that question.
That is also my understanding of the Horizon project, but the product of Horizon project have no obligation with regard to the lawmaking, if you want that way. This is something that is
also not obligation on one hand, and also no direct influence on the legislation on the other hand.
Exactly. Okay. Then I see no more question in the pipeline. We are roughly in time. Thank you very much for keeping into it. I don't want to hold the audience anymore. If there are any questions that might arise in a due time, they can definitely contact you, the audience today.
Absolutely.
I mean, the data has been forwarded, and you will be probably happy to answer them. That brings us to the end of this live talk. I'll try to give you a quick input on what is coming next. First of all, I would like to thank to Butik, who is actually providing the brochure leaflet and also publishing it online for doing that. This is a service that they provide to us already a couple of years. Then I would like to tell you that to the audience that there is going to be a recording in a due time published on YouTube. And last but not least, I would like also to thank Alfred Strauss for co-moderating this live talk. And the next live talk is going to be quite soon. I'm not quite sure, but it's going to be in May. And you will be informed in a due time. Let me tell you, this is going to be on 26th, actually, of April. No, I'm sorry, it's the wrong one. I'm now trying to find it. Yeah, there it is. It's going to be on the 3rd of May. And this talk would be by Sylvia Kessler. She's professor at Hamburg University, and she's going to talk also about the structural resilience. reliability. I'm sorry for that. With that, without further ado, again, thank you very much for the audience and for the questions, and take care and stay healthy. Bye-bye.
Bye-bye. Thank you very much. Bye, Agnieszka.
Bye-bye. Thank you.
Bye-bye, Radi.
Bye, Alfred.